Set 2, problems 1 through 6. Remember our rules. You have to get something written down. You can't keep anything in your head. Be neat. We'll talk about the fourth rule in a bit. I'll let you read the problem. If a screw is 2.5 inches long and has a lead of 1/8 of an inch, how many complete turns would it get it all the way into the wood? Well, it talks about a piece of wood. Let's draw the piece of wood and our screw. Let's label some things. My screw is in the wood 1/8 of an inch. What does that mean? It took me one rotation, one complete turn, to get the screw in 1/8 of an inch. Okay, let's write that down neatly. Okay, so if I turned it 2 complete turns, that's 2/8 of an inch. And immediately I get the idea. 4/8, 8/8 of an inch is 1 inch, that's 8 turns. 16 turns is 2 inches, and 20 turns is 2.5 inches. The name of the game is getting something down. Here's one that I could solve algebraically, but suppose I got stuck. Again, let's create a quick table. Suppose x and y are 12. Why did I choose 12? Because it said if I multiply them together, I get 144. That's the first thing that came to mind. And x plus y are 24. Oh, but wait a second. It says x plus y is supposed to equal 30. And suddenly I see the meaning of the problem. Suppose I choose something else, 24 and 6. I multiply them together, I get 144. I add them together, I get 30. And there I am. Therefore, x minus y equals 18. Trigonometry, the first thing you do, something on the table. A simple little example, you write down SOCRATOA. I didn't used to like this little acronym. I love it now. Well, let's not leave it at that. It says sine of A, so we write down sine of A. Don't just write down sine, write sine of A. And don't neglect to write down opposite over hypotenuse. It makes things easy. The side opposite A is 12. The hypotenuse is 13. It becomes a simple problem. Impossible to get wrong. Salads and soups and sandwiches and drinks. How many combinations can I have of these? Coleslaw, onion, meatloaf, milk. Coleslaw, onion, meatloaf, tea. Potato, onion, meatloaf, cola. You get the idea. It's impossible to count all those, though. Well, suppose instead of 4 different things, we put something on the table, call it thing 1 instead of salads and soups. Thing 1, and we'll say we have 2 of them, A and B. And thing 2, we have 1, 2, and 3. And what are the possible combinations of these? I could have A1, A2, A3, B1, B2, B3. 6 combinations. So if I had 2 of thing 1 and 3 of thing 2, and the total is 6, I know that the way to find the answer is I multiply these together. That's what I'm looking for, is the general rule. I multiply the number of things together. Well, there's 3 salads, 2 soups, 5 sandwiches, and 4 drinks. 120. Volume equals 1/3 pi r squared h. Okay, let's just rewrite that. Sometimes it's easiest for me to write it again so that I can substitute correctly. What equals what? V equals 142. H equals 8.5. I can write that. It's asking me to solve for R. Well, I see that it's an approximation. So why don't I just, instead of 1/3 pi times 8.5, that's a number. If I multiply that out, it's about 8.9. So why don't I just substitute that in? 142 equals 8.9 r squared. Divide by 8.9. R squared equals 16. R equals 4. I start somewhere. I go 9 miles east. Notice that I label everything. I go 12 miles north. About how many miles is the oil rig from the departure point? Let's call that D. We know by the Pythagorean theorem, 9 squared plus 12 squared equals D squared. D squared equals 81 plus 144. D squared equals 225. D equals 15. And in this simple example are really the three most important rules easily highlighted. Get the simple picture written down. Don't just stop there, though. Label everything. Also, I don't just 9 squared plus 12 squared and type it into the calculator. Write it out. There's no sense missing a problem like this. And be neat. That's 1 through 6.